Let g be the function defined by g of x is equal to e to the 2x plus 1 for all real x. Then the limit as x approaches 0 of g of x minus g of e divided by x is equal to one of these options. Okay, so my first instinct here is that this looks a lot like the definition of a derivative, the expression we have here. But is it a derivative of g composed with itself as x approaches 0? I think that is what we get. So this looks a lot like f prime at 0, where f is equal to g composed with itself. Okay, and how do I see that? Well, g of x is e to the 2x plus 1. So g of 0 is e. That's that there. So here I have this is f of x, and this is f of 0, because g of 0 is e. So yeah, well, let's just figure out what this all is. But wait a minute. Yeah, no, this is all right. Yeah, sorry, I was looking at the options given, and none of them looked like anything related to g composed of itself, but I lie, a lot of them do. Options C, D, and E all have an exponential of something with e in it. Okay, so let's just compute g of x. This is e to the 2, e to the 2x plus 1 plus 1. Oh man, do I want to take a derivative of this? Oh, sheesh. Well, maybe I do it this way. F prime of x is g prime of g of x times g prime of x. And what's g prime of x? This is equal to 2 e to the 2x plus 1. Okay, so I need to compute g prime of g of x. This is 2 e to the 2, e to the 2x plus 1 plus 1. And so f prime of x is equal to this, 2 e to the 2, e to the 2x plus 1 plus 1 times g prime of x, which is 2 e to the 2x plus 1. And I'm interested in f prime of 0. So let's collect some things and compute that at the same time. E to the 2 e plus 1 times e. So this is 4e to the 2e plus 2. Is this one of the options? Yeah, it is. That's option E. Fitting. Yeah, assuming I didn't make any arithmetic mistakes, I think conceptually everything works here. But the key was, as soon as I looked at this, I realized, my first instinct was this looks like the definition of a derivative, but it's of course somewhat messed up. It's obviously not the derivative of the function g of x. So if it's not the derivative of g, well, what could it be the derivative of? I notice here that we have g composed with g. So maybe it's a derivative of that, g composed with g. And I noticed that e is g of 0, right? If I compute g of 0, I just get e to the power of 1. And so this does coincide with the definition of the derivative of something at 0, in particular the composition of G with itself. And so then it was just a question of working through the computations to first write out what the function G composed with itself is, then take derivatives and so on. Yeah, so option E, nice little problem. If I have more to say about it, I'll write it in the description. Thanks for watching.